Now we are going to study effect of gyroscopic couple on naval ship during pitching. Now first of all I have to explain what pitching is. Suppose this was ship and here we know this was the rotor which is in this direction, and the rotor is rotating. If the ship goes up and down, so you can see the rotor axis was rotating in this plane. Now it is going rotating and going up and down. Ship is going up and down, and that can be due to any reason, like due to waves. If the ship is going up and down, so what is there? Now you can see there is a axis of spin. Axis of spin is also revolving around something, so there will be a gyroscopic couple. And about which axis the ship is going is the axis is this. So this you axis know, it is the transverse axis. So about transverse axis is called axis of precision. The pitching of a transverse axis is taken to be simple harmonic. So this up and down motion is taken to be simple harmonic, SHM, to simplify the equations. The value of the gyroscopic couple is the magnitude of gyroscopic couple is I omega p, where what does I represent? I represent mass moment of inertia of the rotor. Omega represent constant angular velocity of the axis of spin, the axis of the rotor which was rotating like this. So omega of this, and omega p represents the precision axis का angular moment velocity. What is the precision axis here? The precision axis here is the precision axis here is transverse axis. So transverse axis का angular velocity जो भी होगा, that will be the angular velocity of precision. Angular velocity of transverse axis is omega p. Now there is one more formula derived here, which is I omega into phi into 2 pi by time period. Now what is phi and what is time period? So magnitude of gyroscopic couple is equal to I omega p is equal to I omega into phi into 2 pi upon time period. It came from some derivation which I don't need to do. I omega remains the same if the angular velocity of transverse axis is not given. Suppose this is a ship, and there is a transverse axis through here which is like this. So suppose this is the ship and transverse axis is like this. So if and suppose this both are rigidly connected. So if we rotate the transverse axis, you can see the ship will go up and down. So omega p is the angular velocity of here. If both are strongly glued, if we rotate this, it will go here. If we come back, it will come here. So the pitching is due to the angular velocity of the transverse axis. What does phi represent in the formula? Phi represents maximum कितना एंगल नीचे या ऊपर जाएगा शिप. It is called phi. So नीचे जितना जाएगा उतना ही ऊपर जाएगा. So phi represents the maximum angle कितना नीचे जाएगा शिप. उसे मतलब मैक्सिमम बो अगर लेवल पे है तो कितना नीचे जा सकता है या कितना ऊपर जा सकता है. वैसे दो ऊपर और नीचे जाने के एंगल सेम होंगे. So phi, it represents phi, and put the value if there is no sine or cos or any trigonometric function. Single phi should be written as in radians. What is time period? Time period represents कि 1 second complete करने में कितना टाइम लगता है. Here नीचे गया, ऊपर आया, फिर अपनी पोजीशन पे, नीचे ऊपर अपनी पोजीशन पे, नीचे ऊपर अपनी पोजीशन, या फिर ऊपर फिर नीचे फिर अपनी पोजीशन. सो 1 second कंप्लीट करने के लिए कितना टाइम पीरियड लगता है. ऊपर नीचे से लेवल से ऊपर जाके नीचे जाके फिर लेवल पे आने में कितना टाइम लगता है. दिस इज कॉल्ड द टाइम पीरियड ऑफ time period. Now you found the magnitude of gyroscopic couple. Then how to find the direction of gyroscopic couple? What will be reaction of the gyroscopic couple? So I'm explaining you this thing. Suppose if there is a boat, ship which is going, and due to waves, if the bows goes up, so there will be a there will be a torque applied by the what waves. The waves applied a torque due to which the ship went up. Now, due to gyroscopic couple, the ship does not want to go up, and the waves made it to go up. So there will be a reactive gyroscopic couple which should act in the downward direction. Why? Because okay, so this was the ship, waves made it up. If we see from back side, and suppose the rotor is rotating clockwise, here also we have to do like this. No, I will explain. Here also we have to do the same. Suppose the rotor is rotating clockwise. Clockwise means this. Clockwise means this. Rotor was rotating clockwise, and mostly when the ship is traveling, the rotor rotates clockwise when it is doing a forward motion. In all the machines, it is the same case. So suppose it was clockwise, so L is this side. The direction of L is this. When the ship went up due to the waves, L becomes this. Means, so delta L will be this upper side. If delta L is upper side, so the action torque will be upper side. If the action torque is upper, then the reaction torque should be down. If the reaction torque is down, then by applying the right hand thumb rule, the reaction torque is down. So this step force means the bow will turn right. So the condition is, when a rotor is rotating clockwise, remember what I'm saying, just focus on this. When the rotor is rotating clockwise and due to waves, if the bows goes up, then due to reactive gyroscopic couple, the ship will turn right. Is it right? So let us check from here. When the bow is rising, he has not written the full condition. When the rotor is rotating clockwise and when the bow is rising, then the action couple, don't focus on this. Okay, don't focus on this, just focus on right. When the bow is rising and when the rotor is rotating clockwise, the ship would turn right or starboard side when viewed from the back side. Now when the rotor is rotating clockwise and the bows goes down means this delta L this side means action torque this side. So reaction torque should be up. So it should be like this. So when the rotor is rotating clockwise and if the bows goes down, then the ship also turns left. So this was the case, and for the anti-clockwise you can just do the similar. This anti-clockwise here, and if the this side means this side, and if the bows goes down, suppose bows goes up. If the bows goes up, then it will be like this. So L is in this direction, bows goes up means this. For backside, this is the axis, means this is the L direction. Bows goes up mean this. So action torque will be down, reaction torque should be up. So bow will turn right. Suppose is just going anti-clockwise and the bow is rising. Anti-clockwise, bow is rising. Anti-clockwise and bow is rising means reaction torque will be down. Action torque is down, reaction torque is up. Means bows should turn left. Yeah, bows should turn left when viewed from the back side. This is all when viewed from the back side. If it is from the front side, you can convert it into back side and then visualize. No problem here. So the main here is, so in steering, when we intentionally made the ship to turn left, it was rising up or down, not our requirement of up and down, but it was still doing it. Now when the wave is intentionally moving the ship up and down, it is automatically turning left or right. This we never wanted, but this is left and right is happening in pitching. And in steering, up and down was happening automatically. We never wanted to do, but it was happening. So these are two things which I don't know where these are going to be useful, so just showing you the video.